Welcome. In this video, we're going to find the maximum distance the boy can climb from the base of the ladder before the ladder falls. So, we have been given this diagram where we have the ladder making this angle with the horizontal and the boy climbing this ladder. Then it is a uniform ladder of length 6 meters. So the length of the ladder from this point to this point, it is actually 6 meters. Then we are told to say the weight is 200 newtons, and since it is a uniform ladder, the weight is concentrated right in the middle. So the middle point here. So this is the weight of the ladder, and let's call it weight 1. And then we also have the weight of the boy, which will be here. Let's call it weight 2. And from this point, we have, if it is to slip, it will come this side. But there is a force that is going to counter-react, that is going to oppose the motion of this ladder, which will be in this direction, which is the friction force. At the same time, we have another force that is acting in this direction, which is the normal force or reaction force 1. And also we have another force that is acting in this direction, which is Fn2. This wall is assumed to be frictionless. It is assumed to be frictionless, meaning there's no friction force that is opposing the motion of this. Rather, there is we just have this force, which is the Fn2 here. So from this, we can begin as follows. We know that in order for the system to be in equilibrium, the summation of forces in x and y components must be 0. So we are going to begin as follows. Summation of forces in y must be equal to 0. So in y direction, we have this one which is pointing up, Fn1. Then we have weight 1, and another one, weight 2. So this must be equal to 0. So when we make this the subject, we're going to have Fn1. This must give us weight 1 plus weight 2. Then weight 1, it is the weight of the row, which is 200 newtons, plus the weight 2, which is 1.2 kg times 10 newtons per kg. So that this and this will go, and we're going to have 200 newtons plus 612 newtons, which will give us 84 newtons. The value for Fn1. And again, we know that the summation of forces in x must give us 0. So in x, we just have this one, which is the friction force in this direction, and the opposite direction. So we have Fr1 minus Fn2 must give us 0. So Fr1 must be equal to Fn2. But we know that Fr1 is equal to mu Fn1, this one. So from here we can say where there is Fr1, we put mu Fn1. Mu Fn1 is equal to Fn2. Therefore, Fn2 will give us mu Fn1. Plugging in the values, we know that mu is equal to 0.55. 0.55 times Fn1. Fn1, it is this one, which is 812 newtons. This will give us 446.6 newtons as Fn2. So from this point, we can go on, since we want to find the maximum distance at which the boy should reach so that the beam or the ladder cannot fall. So let me just erase this part. So let us assume to say the maximum distance he can climb is from this point to this point. So from this, let us take the moment at this point. So taking the moment at point, let's call it point P. So taking the moment at point P, we know that or torque, moment of torque, the summation of torque must be equal to 0, or torque, the anti-clockwise torque must be equal to the clockwise torque. So now, from this point, if we take torque to be at this point, let's call this is h, this is height, and then this point, this distance from this point to this point, let us call it x. Then from this point to where the weight is, this will be 3 meters, and this one, the other half will be 3 meters, since this is 6 meters and the weight is actually in the middle. So from this point, we can resolve this one. So this one, we are going to have this theta, and this one will be weight 1 cos theta. And also this one can be resolved so that it becomes perpendicular to this distance. And also we have this one, which is weight 2 cos theta. Theta is this one, so that it becomes perpendicular also to this distance. So we are going to begin with Fn2. So Fn2 times h. So F moment is equal to force times the distance, perpendicular distance. So the perpendicular distance to this is h. So Fn2 times h. So must be equal to, we have this one, the distance, the perpendicular, the force that is perpendicular to this distance, which is 3 meters, is weight 1 cos theta times 3 meters plus, so this one we have weight 2 cos theta, then the distance here is x. It is x. But h, we do not have h here, but we have this angle and we have the hypotenuse. So from Tokatoa, this one, sine 53. Sine 53 degrees must be equal to, opposite is h meters. So that when we make h the subject, we are going to have 6 meters sine 53 degrees. So we can now plug in the values. So we have this one. Before we can plug in, we can do this Fn2 times h. Let us make this the subject by subtracting this cos theta 3 meters, which is equal to weight 2 cos theta x. So that we divide from here cos theta, and also here by weight 2 cos theta, so that this and this will go, and we are going to have x is equal to Fn2 times h minus weight 1 cos theta times 3 meters, everything over weight 2 cos theta. So we can now plug in the values. So from this point, if erase this part, x is equal to, if we subtract 446.6 times 6 sine 53 minus 200 cos 3 times 3 meters, we are going to get 1778.93. Everything over 612 cos 53. We are going to get, patching this on a calculator, we are going to get 4.830. The units meters. So this is the maximum distance that the boy can climb from the base of the ladder until getting to this point before the ladder falls. Thank you so much for listening.